Equilateral and isosceles triangles. Some vocabulary first. First, an isosceles triangle has at least two angles and two sides congruent. So the side that is not congruent on a typical isosceles triangle is called your base. The two angles that are congruent are called base angles. I'll abbreviate that. That's there and there. The two congruent sides are called legs. That is congruent to that. And then the non-congruent angle in a typical isosceles triangle is a vertex angle. Now I keep saying typical isosceles triangle because technically an equilateral triangle is also isosceles. But that would mean all angles and all sides are congruent. You wouldn't worry about what's called a base and what's called a leg. So there we've got some just vocab for us. Now the base angles theorem states that if AB is congruent to AC, so I'm going to go ahead and label some stuff here, A, B, and C. And let's use this triangle down here. Okay, if AB is congruent to AC, then we know that this angle, angle C, and angle B would also be congruent. That's the base angles theorem. The converse of that says, well, if you know that in that same, or in a similar triangle, the AB and C, if you know that angle B is congruent to angle C, then you also know AB is congruent to AC. So, just some information there. If you know your base angles are congruent, then you know the legs are congruent. And if you know the legs are congruent, then you know the base angles are congruent. That helps us when we're dealing with proofs. There's also some corollaries to that. It says that if a triangle is equilateral, then it's also equiangular. So if I know that I have all sides congruent, like so, then I also know that all angles are congruent. And the converse of that is also true. If you know the angles are congruent of an equilateral triangle, then you'll know the sides are also congruent. So just sides lead to angles, angles lead to sides in those different theorems. These two theorems, the base angle theorems and the corollaries. So, all right, so let's go ahead and try to prove one of these things. Or maybe not prove yet. Let's actually find some angle measures. So find the values of x and y in the diagram. So I'm looking at this. I look at this triangle here. And by seeing that all angles are marked congruent, I know that it's equilateral, which tells me a couple things. It tells me that if this is 24, AB is 24, then DB also must be 24. And AD must be 24. Well, that means that 2x equals 24. And if 2x equals 24, then x is going to equal 12. So I found x. Now, looking at this other triangle, the white triangle now, I can see that the white triangle has a side length of 24 and another side length of 24. So the legs are 24, which means this is an isosceles triangle. I could also told that because angle C is congruent to DBC. Okay, notice I had BDC. I had to call this BDC because if I say angle D, I'm actually talking about this entire angle. Okay, whereas angle C doesn't have any other interior angles coming out of it. So I know that that this is an isosceles triangle. DBC is isosceles, meaning that's congruent to that, but it also means that this angle is congruent to this one. So it can help me out if I know what each of these are. And since it's equiangular, which is equilateral, each of those is 60. That also tells me that angle ABD, so this angle right here, plus the measure of DBC equals 180. I'm going to go ahead and mark DBC with 3 markings here since we haven't used that yet. So ABD is 60 degrees. I'm going to substitute that in, plus the measure of angle BD or DBC equals 180. That M angle means measure of angle right here. Okay, and then I'll subtract 60, so I'll get the measure of angle, DBC, is equal to 120 degrees. All right, so this is 120 degrees. And I know that the white triangle here, BDC, made up of 3y, and well, since this is 2 markings, this is also 2 markings, that's 3y. So I have my angle BDC plus my angle C plus my angle DBC has to equal 180 degrees. And we know DBC is 120. Okay, so we know that these 3 angles have to add up to 180. And notice now I have 6y plus 120 equals 180. So that means 6y is equal to 60, and 1y is equal to 10. All right. Very good. So y is equal to 10 there. Very good. Okay, hopefully we all got that. Let's go ahead and try a proof here. Okay, so proof. Given that we have xz is congruent to BA and xy congruent to BY, prove xzy congruent to BAY. Okay. So we're going to do 2 columns again. Statements and reasons. Okay, and so the first piece here, we're going to say, well, xy is congruent to by. And remember, we know side angle side is one way of proving triangles congruent. So if I can use that, xy congruent to by, so that congruent to that, that's a given statement. Okay, that's given. Okay, so now I have a side, and remember, really, it might help you to kind of go ahead and color in what you're trying to prove congruent. So these pieces right here, this triangle, I'm trying to prove congruent to this triangle right here. So I have a side of each of those. There we got it. Okay, and go back to my pen here. I know that based on that statement, that given piece, I know that triangle XYB is an isosceles triangle. And that's by definition of isosceles triangle. I also now know that based on that, I can state that the base angles are congruent. I can state angle X is congruent to angle B because they're both base angles. This and this is a base angles of an isosceles triangle. Okay, that is the base angles theorem. Okay, and remember the base angles theorem, we started out with that today. Okay, the base angles theorem, if 2 sides are congruent, then the angles are congruent. Okay, that's what we just applied right there. Okay, so we now have angle. We have side, angle. If we can just get another side, the included angle is here. We have side, angle. We need this side. So we need xz congruent to BA, or that given statement. All right, perfect. So we know xz is congruent to BA, and that is given. There's our last side. So we now can finish this off with triangle XZY being congruent to triangle BAY is supposed to be a Y by side angle side congruence. Let's go ahead and make that so we can read it. All right, and then finish it off with some kind of ending, whether it's a block